In this example, you are given 3 points A, B, and C, and you are supposed to calculate the angle CBA, and then find the shortest distance between C and the line segment AB. So you can draw something like this. So you want angle CBA. So I mentioned about to find angle between two vectors, the vector must be both pointing out from the same point. So you can consider a diagram like this, BA, BC. So angle CBA is the angle between vector BC and BA. So you'll find vector BC and vector BA. So vector BA is OA minus OB. So you'll be just 2 minus 2, 1 minus 2, 1, 2. You give you 4 minus 3 minus 1. And then you work out vector BC as well. BC is vector OC minus vector OB. So it's actually 1, 0, minus 1, minus 2, 1, 2. And you give you 3 minus 1 minus 3. To find angle this CBA, we'll use dot product. Cosine theta equal to magnitude A equal to A dot B over magnitude A magnitude B. So which means you have to work out BA dot BC. So it means cosine angle CBA is just vector BA dot vector BC over magnitude of BA magnitude of BC. So let's look at B dot A. Vector BA dot vector BC. Let's look at B vector BA dot vector BC. So we just take 4 minus 3 minus 1 dot with 3 minus 1 minus 3. Will give you 12 plus 3 plus 3 equal to 18. And you can work out magnitude of BA, magnitude of vector BA. Magnitude of vector BA is just square root of 4 square plus minus 3 square plus minus 1 square. So it gives you square root of 26. You can work out magnitude of vector BC, which is square root of 3 square plus minus 1 square plus minus 3 square. Minus 3 square. So it gives you square root of 19. So with that, you can sub inside here. Vector BA dot BC is 18. Then magnitude of vector BA is square root 26. Magnitude of vector BC is square root 19. So this is what you have just found. And then you key into the calculator. It will give you angle CBA to be 35.918 degrees. And you can use the angle to find the shortest distance between C and AB. So to find the shortest distance from C to the line segment AB, you drop a 90 degree down. So H will be the shortest distance. And this angle will be 35.918 we just found. And BC, right? BC is square root 19. BC is the length of vector BC. The length of vector BC we have just found is square root 19. Square root 19. So this is square root 19. So we can say h over square root 19 is sine of 35.918. So h will be square root of 19 times sine of 35.918, and this will give you 2.557. So that's the final answer. So you'll find out after you know the angle between vector BC and BA, you can use it to find the shortest distance by considering appropriate trigo function. In this case, you consider sine of the angle 35.918. It will give you h over square root 19, and then you can find h, the shortest distance between C and the line segment AB.